National Electrical Code Section 410.14b addresses exposed wiring from an outlet box to a luminaire, requiring it to be installed in the luminaire support system. Section 410.16b prohibits the use of flexible cord or stranded conductors as branch circuit wiring in premises wiring systems. Considering a scenario where 4-foot surface-mounted fluorescent luminaires are installed in an office building, supplied from a 4S box with a round plaster ring installed in the ceiling serving as a junction box, the compliance with these NEC sections must be evaluated. Assume there are 3 wires, a switch leg, a grounded conductor, and a grounding conductor installed in a conduit. These wires are cut long enough to pull through the box, extending into the fixture via a chase nipple connecting the box and the independently mounted luminaire. First point to consider is whether the wiring is exposed as defined by 410.14b. Since the wires are installed within a conduit, they are not considered exposed wiring. Exposed wiring, in the context of the NEC, refers to wiring that is readily accessible without requiring the removal of any building finish or structure. Conduit provides a degree of protection and containment, thereby negating the condition of being exposed. Therefore, Section 410.14b is not applicable in this scenario. The second point concerns the type of conductors used as it relates to Section 410.16b. If the wires installed in the conduit are stranded conductors, the use as branch circuit wiring directly violates 410.16b. Branch circuit wiring in premises wiring systems must consist of solid conductors or specifically approved flexible cords or cables that are suitable for the application. Stranded conductors, by themselves, are typically not permitted for general branch circuit wiring due to the increased risk of loose strands causing potential faults, higher resistance, and potential overheating at termination points. The code aims to ensure the integrity and reliability of the wiring system. The conclusion is that the described installation is not compliant with the National Electrical Code, specifically Section 410.16b. Although the use of conduit addresses the concerns of exposed wiring under 410.14b, the use of stranded conductors as branch circuit wiring is a direct violation. To achieve compliance, the stranded conductors must be replaced with solid conductors that are suitable for branch circuit wiring, or the wiring method must be modified to use an approved flexible cord or cable assembly that is designed for such applications. In more detail, let's address some of the details of the NEC itself. Firstly, branch circuits are defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. Understanding this definition is crucial in determining whether the wiring in question falls under the purview of 410.16b. Secondly, grounded conductors are conductors that are intentionally connected to earth, forming a return path for current and providing a reference point for voltage. Grounding conductors, on the other hand, are used to connect non-current carrying metal parts of equipment to the grounding electrode system, providing a low impedance path for fault current to facilitate the operation of overcurrent devices. Thirdly, in this context, the switch leg refers to the conductor that runs from the switch to the luminaire, completing the circuit when the switch is closed. It is part of the branch circuit and subject to the requirements of 410.16b. The importance of using the correct type of conductor cannot be overstated. Solid conductors, typically copper or aluminum, provide a more robust and reliable connection, especially at termination points within the junction box and luminaire. They are less prone to loosening over time due to vibration or thermal cycling. Stranded conductors, while more flexible and easier to work with in certain applications, are more susceptible to strand breakage, corrosion, and increased resistance if not properly terminated. In addition, let's explore further NEC sections that might have some relevance. Section 300.3b pertains to the installation of conductors of the same circuit. It generally requires that all conductors of a circuit, including the grounded conductor and any equipment grounding conductor, be contained within the same raceway, cable, or enclosure. This requirement is intended to minimize inductive reactance and reduce voltage drop, as well as to provide a low impedance path for fault current return. Section 310.15 provides guidance on the ampacity of conductors, which is the maximum current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacity of a conductor is affected by several factors, including its size, insulation type, ambient temperature, and the number of conductors bundled together. Section 314.16 provides requirements for the number of conductors permitted in outlet device and junction boxes. It specifies the minimum volume required for boxes based on the number and size of conductors entering the box. Overfilling a box can lead to overheating, insulation damage, and potential electrical hazards. Section 400 pertains to flexible cords and cables. While 410.16b prohibits the use of flexible cords for general branch circuit wiring, Section 400 provides requirements for their use in specific applications, such as for connecting portable lamps or appliances. Flexible cords must be listed and suitable for the intended application and must be protected from physical damage. Section 408 addresses switchboards, switchgear, and panel boards. These are assemblies of switches, overcurrent devices, and buses used to distribute power within a building. Panel boards are typically used to supply branch circuits, while switchboards and switchgear are used for larger services and feeders. Section 250 contains comprehensive requirements for grounding and bonding. Grounding is the connection of a circuit or equipment to the earth, while bonding is the connection of metal parts of equipment to create an electrically conductive path. Effective grounding and bonding are essential for electrical safety, as they provide a low impedance path for fault current to return to the source, facilitating the operation of overcurrent devices and minimizing the risk of electric shock. Let's talk about the practical implications of non-compliance, as non-compliance with the NEC can have serious consequences, including electrical shock, fire hazards, equipment damage, and legal liability. Electrical inspectors have the authority to enforce the NEC and can require corrections to be made to any installation that does not comply. In addition, insurance companies may deny coverage for losses resulting from electrical fires or other incidents caused by non-compliant installations. Therefore, it is essential for electrical contractors and installers to be thoroughly familiar with the NEC and to ensure that all installations meet its requirements. The use of a chase nipple between the junction box and the luminaire is a common practice to provide a secure and protected pathway for the conductors. A chase nipple is a short length of conduit with threads on both ends, used to connect two enclosures or to extend a raceway. However, the installation of the conductors within the chase nipple must still comply with all applicable requirements of the NEC, including those related to conductor type, ampacity, and support. When making connections within the junction box, it is essential to use approved methods and materials. Wire connectors, such as wire nuts or terminal blocks, must be listed for the size and type of conductors being used and must be installed according to the manufacturer's instructions. Improperly made connections can lead to overheating, arcing, and potential electrical hazards. Let's talk about some wiring methods for luminaires. There are several acceptable wiring methods for connecting luminaires, depending on the specific application and the requirements of the NEC. Some common methods include rigid metal conduit, intermediate metal conduit, electrical metallic tubing, flexible metal conduit, and armored cable. Each of these wiring methods has its own advantages and disadvantages in terms of cost, ease of installation, and level of protection. The choice of wiring method should be based on a careful evaluation of the specific requirements of the installation. Grounding is another crucial aspect of luminaire installation. All metal parts of the luminaire, including the enclosure and any exposed metal surfaces, must be properly grounded to provide a low impedance path for fault current to return to the source. This can be accomplished by connecting a grounding conductor from the luminaire to the grounding terminal in the junction box, or by using a metal raceway system that is properly grounded. Proper grounding helps to minimize the risk of electric shock and ensures the safe operation of the luminaire. The NEC also contains requirements for the support and securing of luminaires. Luminaires must be securely supported to prevent them from falling or creating a hazard. The type of support required depends on the weight and size of the luminaire, as well as the type of ceiling or structure to which it is being attached. Common methods of support include mounting brackets, chains, and suspension rods. It is essential to follow the manufacturer's instructions for supporting luminaires to ensure that they are installed safely and securely. Additionally, let's discuss about overcurrent protection, as this is essential for protecting electrical circuits and equipment from overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The size of the overcurrent protection device must be properly matched to the ampacity of the conductors being protected. Using an overcurrent protection device that is too large can allow excessive current to flow, leading to overheating, insulation damage, and potential fire hazards. In addition to the specific requirements discussed above, the NEC also contains general requirements for electrical installations, such as those related to workmanship, access, and identification. Electrical installations must be performed in a neat and workmanlike manner, using approved materials and methods. Electrical equipment must be readily accessible for maintenance and repair. All electrical circuits and equipment must be properly identified to prevent confusion and errors. Compliance with these general requirements is essential for ensuring the safety and reliability of electrical installations. Let's delve deeper into the role of electrical inspections. Electrical inspections are an important part of the electrical safety process. Electrical inspectors are trained to identify potential hazards and to ensure that electrical installations comply with the requirements of the NEC. Electrical inspections are typically required for new construction, renovations, and additions to existing electrical systems. The inspection process may involve a review of the plans and specifications, as well as a physical inspection of the installation. Any deficiencies identified during the inspection must be corrected before the installation is approved. The specific requirements for electrical inspections vary depending on the local jurisdiction. Let's discuss about some maintenance in electrical systems. Regular maintenance is essential for ensuring the continued safe and reliable operation of electrical systems. Maintenance tasks may include inspecting electrical equipment for damage or wear, tightening connections, cleaning equipment, and testing overcurrent protection devices. A qualified electrician should perform electrical maintenance. Frequency of maintenance depends on the type of equipment, the environment in which it is located, and the operating conditions. It is essential to keep accurate records of all maintenance activities. Moreover, let's explore the use of technology in electrical work, as technology is playing an increasingly important role in electrical work. SWOT tools, such as multimeters, clamp meters, and thermal imagers, can help electricians to diagnose problems more quickly and accurately. Computer-aided design software can be used to create detailed electrical plans and specifications. Building information modeling can be used to coordinate electrical installations with other building systems. Online resources, such as the NEC, manufacturers' catalogs, and training materials, can provide electricians with access to the latest information and best practices. The use of technology can help electricians to improve their efficiency, accuracy, and safety. In addition to the technical aspects of electrical work, it is also important for electricians to have strong communication and problem-solving skills. Electricians often work as part of a team, and they must be able to communicate effectively with other members of the team, as well as with clients and other stakeholders. Electricians must also be able to diagnose problems, develop solutions, and implement those solutions in a safe and effective manner. These skills are essential for success in the electrical trade. In summary, the NEC is a comprehensive set of requirements for electrical installations. Compliance with the NEC is essential for ensuring the safety of people and property. Electrical contractors and installers must be thoroughly familiar with the NEC and must ensure that all installations meet its requirements. Regular maintenance and inspections are also essential for ensuring the continued safe and reliable operation of electrical systems. By following these practices, we can help to prevent electrical hazards and ensure a safe electrical environment. The specific scenario presented involves a 4-foot surface-mounted fluorescent luminaire installed in an office building, supplied from a 4S box with a round plaster ring installed in the ceiling as a junction box. The use of a chase nipple to connect the junction box to the luminaire is a common practice, but it is essential to ensure that the conductors within the chase nipple comply with all applicable requirements of the NEC. In this case, the use of stranded conductors as branch circuit wiring is a violation of 410.16b. To achieve compliance, the stranded conductors must be replaced with solid conductors or an approved flexible cord or cable assembly. Additionally, all metal parts of the luminaire must be properly grounded, and the luminaire must be securely supported. The installation must also comply with all other applicable requirements of the NEC, such as those related to overcurrent protection, workmanship, access, and identification. By following these practices, we can ensure a safe and code-compliant electrical installation.